Welcome back to the workshop. We want to take a look at several examples of functions that are one-to-one and onto, or possibly not one-to-one and onto, but we want to discuss and determine which of these characteristics the functions have. So when we're trying to decide if a function is one-to-one or onto, we're trying to answer a couple of questions. Right, we're trying to answer if it is one-to-one or onto, but we can change the question a little bit to help us understand how to decide if it's one-to-one and onto. So if we're trying to decide if a function is one-to-one, it's not agreeing with me here. All right. For one-to-one, we might say to ourselves, if I have two different inputs, will I always have two different outputs? So that's what we want to ask ourselves for one-to-one. If that's always going to be the case, then yes, it's one-to-one. We'll still need to show it, but this helps us understand whether the function is one-to-one or not. For onto, we ask ourselves, can I get all numbers in the codomain? Okay, so if this still doesn't make sense to you, hopefully us asking these questions and looking at these next three examples will clarify it a little bit more. So for this example, we want to determine if the function is one-to-one, onto, both, or neither, and we should justify our responses in each case. So if it is one-to-one, we want to show that it is. If it's not one-to-one, we want to demonstrate why not. So 1, 2, 1. All right. Now, if I put two different integers into this function, well, I always get two different integers out. So if I take a number and multiply it by 3, and I take a different number and multiply it by 3, will I ever get the same number? No, definitely not. Hopefully that makes sense. So this is one-to-one. Yes. 1-to-1. Now we need to show it. So let's show it. Let's let A and B be integers such that f of A is equal to f of B. Okay, so we're taking two integers. We haven't said that they're not the same. We're just taking two integers and we're saying that their outputs are equal. So this is very generic. This could be any pair of integers. We don't know what pair it is. It's just some pair of integers. And the outputs, f of A, is equal to f of B. Okay, the two outputs are equal. Well, that tells us something, right? Because we know what the function is. And in fact, our function is g here, so maybe I should use that notation. G of A is equal to g of B, since our function is g. And so we have plug A into the function, and that's equal to plug B into the function. I divide both sides by A to find, or sorry, divide both sides by 3 to find that A is equal to B. So when I have g of A is equal to g of B, then I have that A is equal to B. So again, thus G is 1, 2, 1. Fantastic. What about onto? Is this function onto? Well, we ask ourselves, can I get anything out of this function? Can I get any integer out? Well, yeah, of course, I could get 1 out, I could get 12 out, I could get 27 out, I could get -30 out, right? That all of these are no problem at all. So sure, maybe it's onto. No, not quite. Okay, you want to think carefully about what types of numbers you're going to get out of the function. In this case, all of the things you get out of the function are going to be multiples of 3. So if it's not a multiple of 3, then you can't get it out of the function. For example, 5. I cannot get 5 out of this function because there's no integer, right? Our domain is integers. There's no integer that I can plug in that when I multiply that integer by 3, I get the number 5 out. So it is not onto. All right, so since 5 does not belong to the range, maybe I could, maybe I should phrase this as since 5 belonging to the integers as part of the codomain. Right, 5 is in the codomain, since 5 in the codomain is not in the range. That is, the range and the codomain are not equal to one another, so it's not onto. All right, let's take a look at another example. So let's determine if this function is one-to-one onto both or neither. And this looks a little bit different. This is a piecewise defined function. So if it's been a while since you've seen a piecewise defined function, just remember that when you evaluate the function, which piece you evaluate it on depends on where those pieces are defined. So our inputs are integers, and we're splitting up the integers into 2 sets, evens and odds. When I plug a number in, I plug it into here if that number is odd. I plug it into here if the number is even. Pretty straightforward. So is this one-to-one? Well, it seems a little bit weird since we have 2 different pieces. Each of the individual pieces, 1/2 x plus 1, that seems to be one-to-one, right? That's a linear function just like this was. That should be one-to-one. And what about this guy, 1/2 x? Again, that's a linear function. That should be one-to-one. So overall, it should be one-to-one, right? Well, not necessarily. There are a lot of values that we can plug in that we would, in fact, get the same thing, or at least one value. So can we find something that when we plug it in, we get the same thing out? Yeah, definitely. In fact, this has many different values that you can choose. So essentially, since it's 1/2 of this, you're just 1/2 of that and 1/2 of that. You're just asking yourself, when are x plus 1 and x the same thing? Well, of course, you have to be careful there because the x here has to be odd and the x here has to be even. But that makes sense because if I take an odd number and add 1, I'll have an even number. So for example, if I chose my favorite number, 17, which is odd, 17 plus 1 is 18. So if I plug 17 in, I get 1/2 of 18, which is 9. But that's also g of 18, right? G of 18 would be 1/2 of 18 because 18 is even. So 2 different inputs have the same output. It is not one-to-one. Okay, it is not one-to-one because 2 different inputs have the same output, right? We have 2 different inputs have the same output. This is not one-to-one. All right, now what about onto? All right, for onto, we actually get yes. Can we get anything? Can we get any integer out of this function? Yes, we can. And in this case, we don't necessarily need to. We don't need to look at it in terms of, you know, oh man, we have some crazy piecewise defined function. How do these 2 pieces play with one another? Well, the reality is you can focus on just one of these 2 pieces. You can recognize that 1/2 x, right? anytime I divide a number by 2, I could get an even number or an odd number. For example, 6 divided by 2 is 3. I could get an even number. 8 divided by 2 is 4. Excellent. So how can I get any number that I want? Well, pick a number. Pick a number. Pick your favorite number. Okay, you got it? Your favorite number. Multiply that number by 2, and it suddenly becomes an even number. That means we would, when we plug that new number, your favorite number multiplied by 2, my favorite number 17, multiplied by 2 is 34. When I plug 34 in, I'm going to plug it into this piece because 34 is even. Then I'm going to divide it by 2 because that's what the function says to do, and I get my favorite number back. Okay, I get 17 back. So any number that you want, you can get out of this function by doubling it and then plugging it in. So yes, it is onto, but we need to show it. So yes, but we need to show it. So let's let y be an integer. But to be clear, we're letting it be in the codomain. And then we want to show that it is in the range of the function. So in this case, we can let x be equal to 2 times y. Then g of x, right? We're trying to show that g of x is equal to y because we need to have that. We need to find some x in the domain. In fact, let me back up here a second. We need to specify, right, x is equal to 2y, but that is also an integer, and it's in the domain, okay? So here's something in the codomain. Our goal is to find something in the domain that has the image y. So here I've identified x, which I'm letting be 2y. This is an integer, which is in the domain, okay? Codomain, domain. So then g of x is g of 2y, which is, right, this is an even number. So I plug it into the second part of the piecewise defined function, and 1/2 of 2y is equal to y. And here, just a nice reminder, since 2y is even, that we want to specify that. That's a good idea. Thus, g is onto. I can get any integer out of that function that I want by doubling that integer and then plugging it into the function. Excellent. One more example for us. Hopefully, by the end of this example, we'll have a really good idea of what it means to be one-to-one and onto. All right. So we want to determine if this function is one-to-one or onto. In either case, justify. Excellent. So one-to-one. We mentioned earlier, right, our first example was a linear function, and it was one-to-one, but it was not onto. So we suspect maybe this linear function is also one-to-one, and it is, right? If I plug any number in, if I plug 2 different numbers in, so 3 minus one number and 3 minus a different number is never going to give me the same thing, of course. 3 minus 15 is not going to be the same as 3 minus any other number. So, yes, let's show it. So let's let a and b be integers such that g of a is equal to g of b. So when I take 2 outputs that are equal, I need to show that the inputs are equal. Anytime I have equal outputs, I should have started with equal inputs. The only way to get 3 minus 15 is by plugging in 15, for example. Okay, Saying that specific example is not a justification for why it's one-to-one. Saying that specific example is a way of us understanding that, yeah, we believe that it is one-to-one. Here, we show it with certainty, with generality. All right, so let's say we have two different numbers in the domain such that their outputs are equal. Then we would have 3 minus a is equal to 3 minus b, since that's g of a and that's g of b. Of course, I can subtract 3 from both sides to get negative a is equal to negative b, and then multiply by a negative 1 to get that a is equal to b. Fantastic. That's what we're looking for. So g is 1, 2, 1. Excellent. Well, what about onto? Do we have that this function is onto? Can I get any integer out of this function? I suspect yes. I suspect yes. Right, because what I can do is I can take 3, and if I'm just subtracting x, I can move up or down by whatever I need to get my favorite number. So 17, how could I get 17 out of this? Well, 3 minus what is 17? Well, 3 plus 14 is 17, so 3 minus a negative 14 gives us 17. Okay, so I can think of it that way. And just because we got it to work for one number doesn't mean we can get it to work for every number. But if we write it in a generic way, then that might work. Okay, so if I wanted to get any number out of this, right? If I wanted to get, let's see here, just maybe a quick side note here. If I wanted to get y out of the function, right, 3 minus x is equal to y, how could I find out what I need x to be? Well, of course, I can just subtract 3, so negative x is equal to 3 minus x, 3 minus y. But then I would also need to multiply by negative 1 to get that x is equal to y minus 3. So that's what I believe my y should be for the onto portion of this. Okay. Oh, actually, I wrote that backwards. Subtract 3 to give me y minus 3, and then multiply by negative 1, so 3 minus y. Yep, that makes sense. All right, that agrees with what I found for my 17. 17, to get that, I would have to plug in negative 14. 3 minus 17 is negative 14, so this here suggests the same number. So that looks good. So I suspect yes. And before I write up my final answer, I should know what on scratch paper what the answer actually is. So maybe I would do this on scratch paper first for my own work that you might want to do, since that's exactly what you'll be handing in, this handwritten work. So let's let y be an integer in the codomain. Now, the reason that I'm specifying codomain here is because my domain and codomain are the same. So I want it to be clear as to which one I'm referring to. All right, so let y be in the codomain. Then x, we want to be 3 minus y, is also an integer, in this case, an element of the domain. And we don't have a ton of room here, so I'm going to work a long string of equalities. And g of x is equal to, of course, g of 3 minus y, because we're saying those are equal. Plug that in, and I'm going to have 3 minus a 3 minus y. 3 minus 3 is 0. Let's see here, and then minus a negative y gives us a plus y. Thus, g is in fact onto. Excellent. So I can get anything, I can get any integer out of this function, which means that it is onto the set of integers. All right, so that's 3 examples of functions. Some of them are one-to-one, some of them are onto. This one is both, and the other ones had it swapped, right? The first one was onto one-to-one, but it was not onto. And this one is not one-to-one, but it is onto. And this one is both. And the ones that are both are of special interest to us, and we'll take a look at those in our next video. So thank you for your time. I'll see you guys back in the workshop in just a moment.